Now I am going to teach 12th standard physics lesson number 4, content number 4.9.1, energy conservation during LC oscillations. So already we learned in lesson 1, in capacitor energy stored in the form of electric field. In lesson 3, in inductor energy stored in the form of magnetic field. Energy given to the LC circuit, electric field and magnetic field, that is energy oscillate in between electric field in capacitor, magnetic field in inductor. So produced electrical oscillation of definite frequency are generated. These oscillations are called LC oscillations. Next, generation of LC oscillations. Let us assume that first in figure 1, so capacitor is fully charged with a maximum charge Qm. At this initial stage, capacitor is fully charged with a maximum charge Qm. So energy stored in the capacitor is maximum, that is UE. UE stands for energy stored in the capacitor, that is UE equal to Qm square by 2C. Qm means maximum charge. Now current is not flowing through the inductor, current is 0. So magnetic field in the inductor is 0. So total energy is wholly electrical energy. Now case 2, capacitor as starts discharge. Now current flowing through the inductor. So in inductor energy stored in the form of magnetic field. In capacitor charge decreases, that is UE equal to Q square by 2C. In inductor magnetic field energy stored in the form of magnetic field UB equal to Li square by 2. So here total energy is equal to sum of electrical energy in capacitor, magnetic field, magnetic energy in inductor. So U equal to UE plus UB, that is U is total energy of the LC oscillation circuit, is equal to UE electrical energy in capacitor, magnetic energy in inductor. So U equal to Q square by 2C plus half L I square. Case 3, so capacitor is fully discharged, that is no charge in the capacitor. So current flows through the inductor is maximum, that is Im. Im stands for maximum current flowing through the inductor. So magnetic field around the inductor is maximum. So here electric field is 0, magnetic field is maximum, that is UB equal to Lim square by 2. Im stands for maximum current flowing through the inductor. So here total energy is wholly magnetic energy. Figure 4, charge in the capacitor 0, but current I flows in clockwise direction. So now capacitor charging in opposite direction by decreasing the magnetic field in inductor. Some part of energy transferred through the capacitor, some part of energy transferred to the inductor. So total energy of LC oscillation the circuit is equal to sum of electric energy in capacitor, magnetic energy in inductor. Figure 5, current in the capacitor is 0. Now capacitor is fully charged, current flows to inductor is 0. So capacitor stored maximum charge. Here no magnetic field developed around the inductor. Here magnetic field around the inductor is 0. So total energy is wholly kinetic, that is electrical energy. in diagram 6, this state is similar to the initial state, but only one small difference. In initial state, capacitor store charge in forward direction, here capacitor charging in opposite direction. So the capacitor starts to discharge through inductor with anti-clockwise direction. Current flows in anti-clockwise direction. So total energy is sum of magnetic field and electric field. As already explained, the process are repeated in opposite direction. Finally, the circuit returns to the initial state. When the circuit goes through the stages, the alternating current flows in the circuit. As this process is repeated again and again, the electrical oscillation of definite frequency are generated. These are known as LC oscillation. For ideal LC circuit, there is no loss of energy. Therefore, the oscillations will continue indefinitely. Such oscillations are called undamped oscillations.